Hi, Joe McVeary. We're back with our fourth video. In this video, we're going to change the result attribute from a numeric to a nominal value, two nominal values of possibly of being a buy or a sell. So we'll bring up to do this quickly, we'll bring up the original program, and then we'll just do simply save as to make another copy of it. With nominal values.java, lowercase I, do a save. Eclipse wants us to make sure that the class name is correct. Let it do it for us. Let's go down to the result attribute, which right now is defined as numeric, and we'll put in the nominal values of buy or sell. Braces. And let's change the output routine. Let's make this bigger so it's easy to read. And we'll just do the old inline logic statement. If it's the next day close is greater than the current day close, we're going to kick out a buy signal. Otherwise, we'll kick out a sell signal. Close it and save it. Let's delete the old R file. We don't have to do that, but just to be on the safe side. And run it. Refresh. Let's take a look. Here's now the nominal possibilities of buy or sell, and then as you can see that the result field has been changed. Okay, so let's jump over to the WEKA Explorer. Open our newly built R file. As you can see, we still have our current price attribute along with the moving average fast, slow, but now result is a nominal. It can be only two values, buy or sell. Buy, we have about 3,400 incidences of it, and the sell there are 2,930. Let's start with the classifiers, and we'll start with the default 0R. Quickly runs. Let's take a quick look at the confusion matrix, and as you can see, the results aren't very good. Everything's being thrown over into the buy column and none in the sell column. So obviously this classifier isn't very good. One other field I'd like to look at is the precision weighted average on the bottom line for all of the runs, and we're only getting about a 30% correct rate. So that's pretty bad. Let's fire up another classifier. We'll try one of the naive Bayes. How's that? Again, almost the exact same results. It is the same results. Actually, the precision seems to be a little lower. I don't know why. But I do know that this complement naive Bayes runs pretty well. And in this case, we are getting a good mix of buy and sell indicators, where there are some in the sell side. But if we look at the precision now, we're up to 0.52 or 52%. Which is a lot better than what we were getting with the previous two. Next to look at is functions, and these two weren't available to us. liblinear and libsvm weren't available to us because we weren't before. In the previous video, we were using a numeric attribute for our classification, Let's run liblinear. These seem to take a while. Actually, you'll see the libsvm does take longer. Okay, we're getting some by's and some cells, but our precision has now fallen off to about 50%. libsvm. Building the training model. And now we're doing the folds. So after about 2 minutes, the test is done for libsvm. In this case, we're getting pretty good precision there at 0.52, and our confusion matrix verifies that. Next up is my favorite, random forest, which is down in the trees. This one takes a while to run. It's slightly faster than libsvm. Okay, random forest should be finishing up here, and there it's done. We have a precision of 0.52. One more we're going to look at is JRIP. So there is a rule. JRIP, which is in the rules. And we're set and go. It should be pretty quick. It is. Precision 0.505. So as you can see, with a 0.505 and the good ones that we picked out at about 0.5%, that's really pretty much like a correlation coefficient of near zero. So this process of using a nominal classifier hasn't helped us at all. So here are the best 5 results for the classifiers we ran. In the next video, I'm going to add a 5-day look ahead to both of the numeric and nominal ARF files. Until then, if you like what you see, press the like button.